presenter is Skylar Knickerbocker. And other than having an awesome name, Skylar has graduated from the University of Iowa. I'm sorry. Iowa State, and with a master's degree, right? And you have your bachelor's degree from, where is it? Missouri University. Good Midwest guy coming up here. And he's been doing a lot of projects, Sharp 2 projects, worked for the Iowa Department of Transportation and the Midwest Transportation Center. And if you have any other awesome things you want to tell us.
All right, so I'm going to present on some corridor performance that we're doing for the Iowa DOT and how this has kind of evolved into more of a quality tool for the Iowa DOT. So as you all know, we live in this day where there's a ton of data there, and we can ask a ton of different questions and be able to get answers from being able to use that data. But a big step first is looking at the quality of the data. So our goal with the Iowa DOT and us supporting them is to provide the most current, accurate data available for them to make decisions both in real time and historically. And that first point is the accuracy of the data and making sure that the data we're using to help them make the decisions is accurate. So a little background with the Iowa DOT, they started deploying sensors around 2005 in just the Des Moines area and putting them out there, and then they started expanding to other locations across the state. Their major urban metro areas, they would deploy it. And I used to always think it was funny whenever I would go to their ITS Heartland meetings, and you have each state get up and present and say what they were doing the last year. And it would always be, we put out 50 sensors, or we put out 75 sensors. And then you would start to ask them what they actually do with the data, and they would say, oh, we got the sensors out there. And none of them were actually doing anything with the data, or at least the Iowa DOT wasn't doing anything with the data, or even looking at the quality of the data. So in 2013, we started a support contract between Intrans, Iowa State University, and the Iowa DOT's Office of Traffic Operations. And they had all these big questions that they wanted to answer. And the first step that we did was just look at the data and realize that the data quality was horrible. And a lot of these sensors either need to be recalibrated, or they end up replacing a lot of the sensors that were performing poorly and replacing them with new sensors. So this is a map of all of the sensors across the state. Right now they've got around 300 to 400 sensors. They also have IWZ program where they deploy additional sensors on trailers, which I'll talk about tomorrow in session 3A. But you can see they're mainly in the metro areas. So you got Des Moines right in the center of the state, the Iowa City, Cedar Rapids area, Waterloo, Sioux City, and Council Bluffs. And so they're in these main corridor areas, and what we wanted to do was look at this data and see if we could do some performance measures and have a QA tool that they could look at their sensors and provide to their maintenance contract vendor to actually use to go out there and proactively try to recalibrate sensors before they really start getting bad. So like I said, data quality was a major issue. What they did up until around 2014 and 15, whenever we started really working with the data, was just IP monitoring. So they would check and make sure they could ping the sensor every so many minutes, and there was no checks on the data quality. So the first thing we did was have this Heatmap and other performance measures that we could look and do some just easy quality scores of checking if we're just constantly getting zero speeds. What we saw a lot was heat maps like this, where you'd have a sensor just completely offline in zero speeds, which is this black bar, or we would see erratic speeds. We call it the kind of rainbow effect, where you're going red, yellow, green all the time, and the speed's just all over the place, and we know that's not what's going on there in the roadway. Continuous low volumes. So you can't really tell it here in the speed maps, but we would see either continuous low volumes or potentially even continuous high volumes, where they'd be saying there's millions of vehicles going in a 5-minute period, which not happening anywhere, but especially not in Iowa, that's not happening. And then vehicle classification. They ran into a problem with whenever they switched to Wavetronix HD sensors. that they just weren't getting any class vehicle data. And we caught it within about a week once they started putting the new sensors out there. But if we hadn't have caught it, who knows how long it would have actually been before they would have realized that they weren't getting actual vehicle classification from any of their sensors. So we initially developed this tool for work zones to be able to monitor, which, like I said, I'll present more on in session 3A tomorrow. I'm just going to hit some of the high points that I don't mention in the session tomorrow. But they wanted to expand it to the corridors because they did like the value of being able to monitor their IWZ sensors and seeing the quality of the data that they're getting from there and expand it to their corridors across the state. So that's what we ended up doing, and we update this tool on a daily and a weekly performance measure. We have a similar setup as CATT Lab and Michael, but we use Tableau for all of our visualizations. But we do have a Hadoop backend as well. The interactive tool that we use is all web-based so that the DOT can have access to it at any point. The main modules that we have is an overview map, just showing you each of those corridors across the state. Then the heat map part, corridor performance, sensor performance, and the volume, the hourly volumes. And I got it late this morning, but I'm actually just going to talk about the heat maps and the hourly volumes. So this is the landing page on the tool. Once you log into our website, you can see all the corridors across the right side, as well as a map that shows you a point of each corridor. Selecting either the point or the names on the right side will take you to the heat map, and so it will default to the last 7 days. And kind of getting to the point of what, I didn't get your name, but what we actually incorporated into this is that imagery there up in the top left corner of if you hover over any of the sensors here and the locations, it actually updates that map to show you the closest camera image. So you do get that visual perspective of what was going on in the roadway and whether it was a false call or whether it was actually a true event. And this has really been something that the DOT really wanted because they can trust us as much as they want, but sometimes they just need to see it to really confirm it and believe in it. So up at the top, you can see the different modules that you can go between to filter. The main part is the heat map portion. So we've got the eastbound direction and the westbound direction. Like I said, there's 7 days of traffic, or 7 days, previous 7 days there, and the sensors are ordered. You can kind of tell there's distinct lines, and that's because that's what each of the sensors along the corridor. Then we also have some scores. So we have a PC score, the error rates, and then the average speeds. So a combination of these is kind of a quick indicator of what the quality of the data is. The PC score is a mixture of those four measures that I said that we calculated error with. The error rate is just how many times we're getting no data. So the little black bands represent that. And then the average speed just is a quick indicator of whether you're just getting 0 speeds that entire time. In the top right corner, we've got toggles to filter back in time. Like I said, it filters the last 7 days, but you can go back to previous months and the last year and see what the data was during that week and see how the sensor was performing at those time periods. And like I mentioned, whenever you hover over any of the time periods and that sensor, it finds the closest corresponding imagery, as well as highlights the map and show you where exactly you are within the corridor. The other portion of this is our hourly volume plots. So with the sensors, we can actually get the hourly volumes to what the DOT is really using it for is to make decisions on when they can close the lane. This actually is going to be incorporated into their lane closure planning tool, which they're using and planning on deploying to anybody that's going to close the lane on the roadway or do any work on the roadway would have to get approval from the DOT and using that volume data from those sensors to make the decisions. And the reason they like this is because we're actually using box plot instead of just the average, which is what they were using previously, because the box plot gives you that range and how much variability am I seeing in the volume. which will have an impact of whether they can close the lane. So they normally use a threshold of 1,350 vehicles per hour per lane. So we calculate the hourly volumes, and they can use that to decide whether they need to close the lane or whether they should wait till after the morning rush or the afternoon rush to close those lanes. And like I said, or the same filter at the top right corner, you can filter and go back in time. Box plot shows the hourly volume range. We throw in the average speed just to give them a reference of how speeds are. And in most cases, Iowa looks always this way, where it's pretty consistently around 60 miles per hour in the metro areas at least. And then you can choose a sensor. So if you wanted to find to a specific location, instead of giving an average over the entire corridor, that allows you to kind of narrow into where you actually are going to be closing the lane instead of looking at the entire corridor. And that's all I've got. It's a combination of myself, Neil Hawkins, and Anu Sharma at Intrans. So I guess open up the questions.
Absolutely.
How do the sensors know what vehicle it's just a technical question.
Sensors, so it's side-fire radars, Wavetronics, or the Iowa DOT is all Wavetronic sensors now. But they're just side-fire radars, so they're detecting the vehicles passing by, and they can get vehicle speed, classification, and count for each sensor that's passing by, and they'll get it in by lane, and then we aggregate it up to the entire roadway.
So there are no infrared sensors now?
The DOT does. Well, they still have ATRs that use loop detectors, but even then they're moving more towards the Wavetronic sensors because the construction office doesn't always communicate with the planning office, so then construction will reconstruct the next year that right after they put the ATR or the loops in and tear up all their loops. So they've just decided that the data and the quality is good enough with Wavetronics, the locations they're interested in.
How about signals?
Iowa DOT doesn't do anything with signals. Yeah, they leave that all to locals.
Do your radar detectors, are they recalibrating them every year? And
So that's part of the reason that we that they've gotten a more regular regimen of recalibrating them. They had a certain criteria for their vendor. I can't remember what the actual terms were, but we're actually reevaluating that now based on the historical sensor performance to see whether we actually need to be going out and actually touching the sensors more often to recalibrate them, or whether we could extend it and say they don't have to go out there as often.
that's been the biggest problem in Texas, is that if they don't do it every year.
Yep. And I want to say it's every 6 months is what they say, but I don't know if they actually do that.
Yeah, it's starting to do that.
Back to back.
For the video data, are you recording video and keeping it so you can go back in time?
So it's snapshots, so we're recording right now. The DOT does have a video archive, but they only store it for, I think, 5 days. But that is one of the things that we want to start doing is at least getting clips of videos, because the camera imagery is definitely a major step forward, but it's hard to tell if it's just traffic moving at a uniform speed that's not a slowdown, or whether it actually is just stop traffic. So we're wanting to try to get maybe like a 5 or 10 second clip that you can actually hover over and it'll play that.
And the DOT doesn't have any problem with that? Because at least in Texas, they don't want us to record.
That's because they don't want to do a public record request.
Yeah, and we're university, so we haven't ran into that problem.
You're recording it, not
Just let them do it.
Yeah. They haven't told us no, and we've got a support contract that we do everything with them and agreements with them, but we don't get requests.
One more? Anybody? I've got one. It's not related to visualization, but Iowa DOT, I believe, is also purchasing probe data from the vendor.
Interest.
Okay, are you seeing any sort of conflict now between those who want to use probe data versus the older school but perhaps still necessary detection network?
Oh, I think Scott has been here. Marler, Officer Sharp out there, is very good. Been to your Ops Academy, so he's pushing towards the probe data. And so it's kind of a balancing act right now of what do we do? Because they like having that volume data. You can get actual counts of vehicles out there, which the probe data doesn't have. So they're kind of in this limbo of using both right now because they have the sensors out there.
Yeah.
But I guess they haven't ran into the problem of whether they actually want to start replacing the sensors or not. So they work right now and they're good to go. So we'll evaluate it later.
Very nice. All right, thank you very much, guys.